Xi Jinping personally visited Serbia to sign a joint declaration on the Sino-Serbian community of a shared future, with the aim to build a strategic partnership of shared destiny. However, the glittering slogan should not obscure the real intentions and potential negative consequences of this so-called community of shared destiny. Let us turn to another country that has already fallen into this trap, Bangladesh. Several years ago, Bangladesh purchased several 159G tanks from China, touted for their superior performance and affordability. In April this year, Bangladesh received a new batch of these tanks. On May 4th, during testing, one of the 59G tanks exploded while firing its 31st shell out of the planned 60, resulting in the death of the loader and severe injuries to the commander and gunner. The Bangladeshi military immediately suspended the use of this batch of tanks. The Chinese and Bangladeshi military authorities swiftly initiated comprehensive lockdown measures, attempting to conceal the true nature of the incident. However, confidential intelligence obtained by lewd media fully exposed the details. Design flaws and recoil system failures. The breech could not seal properly, allowing high-temperature gases to leak and shatter the breech block, severely injuring the commander and loader. Inferior quality of protective panels. Made from cheap aluminum alloy, these panels lack sufficient protection to effectively safeguard the crew. Following the accident, Chinese technical reports quickly shifted the blame to Pakistani-manufactured shells and the 3 Bangladeshi tank crew members. However, the details in the accident report ruthlessly revealed the real cause of the incident. Bangladesh 59G tank incident. The Chinese Communist Party treats allies as cannon fodder. The firing process for the tank's ammunition involves the shell being automatically ejected from the breech after firing to make room for the next shell. This is controlled by a mechanism known as a breech block. If the breech block functions properly, the spent shell casing should eject smoothly, the breech should seal promptly, and the next shell can be safely loaded. In this incident, however, the breech block was severely misaligned by 152 millimeters, causing the spent shell casing to jam in the breech, unable to eject. If another shell were loaded under these circumstances, the breech could not fully seal, leading to catastrophic consequences. Moreover, the 59G tank lacks necessary safety mechanisms in its design. Normally, if the firing system, which is a recoil system, fails, the tank should automatically stop loading to prevent further accidents. But the 59G tank did not account for this, allowing loading to continue. This is obviously a serious and irresponsible flaw in the design. Consequently, the shell fired in an unsealed breech released a large amount of high pressure gas into the crew compartment, causing severe burns to the crew. The breech block, supposed to seal the breech, shattered instantly under the high temperature and pressure, striking the gunner and loader in the head at high speed. Additionally, the crew should have been shielded by the tank's protective panels, but the 59G's panels were made of weaker standard aluminum alloy, far inferior to the specialized alloy steel used in Western tanks. To worsen matters, this fragile protective panel was also removed during the incident, completely exposing the crew. Overall, the 59G tank exhibited serious deficiencies in breech sealing, the strength of critical components, and protective measures, highlighting major issues regarding the quality and reliability of Chinese weapon systems, ultimately leading to this preventable tragedy. After the accident, the Chinese attempted to blame the quality of ammunition produced by Pakistan Ordnance Factories, POF, or attributed to errors by the Bangladeshi soldiers. The Chinese report claimed that poor ammunition quality led to the failure of the recoil system, or that the soldiers did not operate according to procedure. However, the Bangladeshi soldiers, either deceased or severely injured, cannot refute the Chinese accusations, and the veracity of China's statements is impossible to verify. POF is a long-established military enterprise whose ammunition is widely used by several countries' armies, including Pakistan's. If there were issues with the ammunition quality, the Pakistani military would be the first to be affected, yet no similar incidents have been reported. The UK has extensively purchased ammunition from POF for use by Ukraine. As a developed country, the UK has strict standards for military quality, and their choice to purchase from Pakistan and supply it to allies itself indicates a recognition of the product's quality. The Ukrainian military has also not reported any issues with Pakistani ammunition. The tank's recoil system should have been designed to accommodate unexpected situations like deformation or damage to the shell casing, with a certain level of fault tolerance. If a malfunction due to shell quality alone caused a recoil failure, it reflects a flaw in the tank's design, not an issue with the ammunition. The technical report on this accident is not accessible to senior officials in Bangladesh or many in China, as China's Military and Defense Equipment Authority usually reserves such sensitive information for a select few high-ranking military officials, with major regional commanders also uninformed. This indicates the extent to which the Chinese are attempting to cover up the incident. However, the fact that lewd media could obtain this information suggests that someone within the Chinese system, delusioned with the regime, are unwilling to continue supporting it and are looking for ways out. Corruption and mismanagement in the Chinese military industry. Systemic issues. The Chinese military-industrial complex has long relied on reverse engineering and imitation technologies, dismantling foreign advanced weapons to replicate their structures and processes. However, this approach has a significant drawback. Chinese technicians often follow the original designs without a deep understanding of the underlying logic. When they attempt to further optimize these designs, unintended problems can arise due to unclear rationale behind certain key configurations. The development of weapons involves multiple disciplines such as mechanics, materials, and processes, placing high demands on the designer's knowledge and experience. There is a general shortfall in these areas among Chinese military-industrial personnel, which is a significant reason for the decline in the quality when attempting to improve weapon designs. Moreover, defects in material selection and process control are key factors leading to unstable performance of Chinese military products. For instance, high-strength steel requires strict control over component ratios, impurity content, and quenching processes. Developed Western nations have long-standing accumulations in these critical materials and processes, establishing comprehensive databases and quality control procedures, allowing their weapon components to function reliably under various harsh conditions. Although China has access to advanced weapon designs, it lacks knowledge of these critical process parameters. Coupled with weaknesses in foundational industries, even direct replication of designs often fails to meet the original standards, let alone for optimization. In weapon development, the choice of materials and control of processes are crucial. Even minor deviations can significantly impact the performance and reliability of the final product. For example, in firearm manufacturing, if the composition of materials and critical components like gun barrels and bolts deviates slightly, or if the heat treatment temperature or duration is off, it can fail to meet strength, toughness, or wear resistance specifications, affecting the firearm's reliability and lifespan. Specifically, a few seconds deviation in the quenching time of gun barrel materials can lead to uneven hardness, causing stress concentrations during use and premature barrel failure. If the material composition of the bolt does not meet standards, its strength and toughness may not withstand the demands of high-speed motion, potentially leading to jams or breaks during automatic loading. The underlying issue is the weak foundation of China's materials industry. Crucial materials such as high-quality special steel and high-strength aluminum alloys are either below the needed technical level or have limited production capacity in China, necessitating reliance on imports. With escalating sanctions from Western countries in recent years, critical material imports have been increasingly cut off, forcing the Chinese military industry to turn to domestic substitutes, which further degrade product quality. The Chinese government promotes these national treasures, showing computer numerical control precision manufacturing with mirror smooth surfaces and nearly invisible seams between components. However, these are often selected for promotional purposes, with the highest machining precision samples chosen for display. Once mass production begins, quality assurance becomes unattainable. Why can't the Chinese military industry solve these problems? The corruption in the Chinese system, pervasive from top to bottom, ensnares the entire military-industrial system. At the highest levels, military officials often view arms procurement as an opportunity to line their own pockets, opting for the cheapest solutions during the procurement process to maximize their kickbacks. Critical phases such as design optimization, material improvements, and rigorous testing are often neglected in a bid to cut costs. Furthermore, corruption extends to grassroots military enterprises. Although military representatives are stationed in factories to oversee quality, They often collude with factory officials, accepting bribes and turning a blind eye to quality issues with key components. To save money, some manufacturers even use substandard materials, such as the 59G tank's protective panels made of weak standard aluminum alloy. Driven by self-interest, military representatives allow substandard products to pass through multiple checks, ultimately entering into service. This time, the incident with the 59G tank in Bangladesh has a significant impact on the morale of the Chinese soldiers. It is reported that the People's Liberation Army (PLA) has equipped up to 2,500 59G tanks with approximately 7,500 soldiers operating these tanks. If the 59G tanks were to fail on a large scale in combat, the consequences would be dire. In the third batch of 59G tanks delivered to Bangladesh in 2022, 2 out of 6 new vehicles exhibited quality issues. Should war break out with harsh battlefield conditions, enemy actions, and various uncontrollable factors, it is feared that more 59G tanks could face mechanical failures. Considering the large number of 59G tanks in the Chinese arsenal, a widespread failure during combat could potentially reduce the combat effectiveness of the People's Liberation Army's armored forces by 1/3, leading to the needless sacrifice of thousands of tank operators due to equipment quality issues. The technology behind the 59D tank, based on the mature 59 series, should be reliable. Yet even this established armored platform cannot escape the fate of substandard quality under the Chinese military-industrial production process. Compared to the Army, the Air Force and Rocket Force have even higher requirements for materials and processes. If tanks frequently malfunction, the reliability of fighter jets and missiles is even more questionable. The false community of shared destiny, concealing the truth and shifting blame. Bangladesh is heavily influenced by the Chinese Communist Party, and there is a certain degree of censorship within the country. The CCP, in collaboration with the Bangladeshi military, fearing that exposure of the 59G tank incident would severely damage the image of the community of shared human destiny, quickly blocked information and banned media coverage related to the incident. Previously reported by Bangladeshi media, the delivery of 59G tanks in Chittagong in April was removed from publications following the incident. The explosion of the 59G tank, which caused severe casualties, prompted rigorous accountability reviews from the 7th Bangladesh Regiment. The CCP's Defense Science and Technology Agency and the Military Commission intervened swiftly in the investigation, attempting to shift the blame onto issues with Pakistani ammunition or operational errors by lower-level Bangladeshi personnel. They tried to coerce on-site personnel to claim that the malfunction was not due to the Chinese tanks, but rather the incompetence of the soldiers or their failure to follow proper operations. This is a typical blame-shifting strategy, silencing Bangladesh to downplay the incident. Even if the media were to expose and interview those involved, since the tank commander, gunner, and loader were either severely injured or killed, it would be portrayed that the accident was their fault, absolving the CCP tanks of any responsibility. Meanwhile, the CCP has excluded all other stakeholders from any blame, including the commander of Regiment 7, the Bangladeshi Defense Ministry, the CCP's 902 workshop in Bangladesh, Northern Industries Company, and military representatives, all in exchange for their support in blaming the 3 soldiers. The reason China operates this way is to prevent the inherent design flaws of the tanks from being exposed and to keep the poor quality of CCP military equipment from being revealed, as the same series of weapons are still being marketed internationally. The CCP continues to sell this substandard military hardware to countries like Serbia. Why does China want to export its weapons around the world? Unlike the United States, which establishes military bases openly worldwide, China aims to maintain geopolitical control in South Asia, Africa, and Eastern Europe without such overt bases. Thus, under the guise of the community of shared destiny, China provides loans and military equipment to place some countries under its debt and military control. Then, by sending technicians to provide relevant training and maintenance services, China establishes close military cooperation with these countries. When conflicts arise in these regions, China can directly activate and use these weapons to secure its geopolitical interests. The fragile alliance behind the political gang, the China-Russia alliance. China and Russia boast themselves as leaders in an anti-Western alliance aiming to bring smaller nations under their influence. However, the alliance is more like a hierarchical, interest-driven political gang. Within this alliance, countries like North Korea, Iran, Syria, Serbia, and Bangladesh play subordinate roles. China and Russia provide them with limited economic and military support, but impose harsh conditions, often requiring these junior partners to contribute local human resources and even sacrifice their soldiers. For instance, Russia's actions in the Syrian conflict illustrates this dynamic. To support the Assad regime, Russia has employed its air force to bomb the Syrian opposition. However, on the ground, Russia mainly relies on ground troops provided by Iran. These Iranian soldiers act as cannon fodder for Russia, fighting on the most dangerous front lines. Statistics show that over the past few years, thousands of Iranian soldiers have been killed on the Syrian battlefield. Through this conflict, Russia has solidified its influence in the Middle East and satisfied its geopolitical ambitions. As Russia faces setbacks on the Ukrainian battlefield and China's economic growth slows, the blood transfusion capability of both nations has decreased, leading to reduced aid and diminishing benefits for the smaller countries, which begin to question the commitments of China and Russia, growing dissatisfied with the alliance. For example, China, under the guise of providing loans, induced Sri Lanka to build the unnecessary large port of Hambantota. The construction was primarily carried out by Chinese workers, offering little employment or economic benefit to the local Sri Lankan populace. After the port's completion, unable to repay the high Chinese loans, Sri Lanka had to lease the operational rights of the port to China for 99 years. China, using the debt trap strategy, effectively took control of the strategically significant port in the Indian Ocean. North Korea gradually realizes that it gives more than it receives in the alliance. Iran doubts whether China and Russia can fulfill their commitments on issues in Syria and Yemen. Bangladesh, from the 59G tank incident, considers withdrawing from the alliance. Western countries' strategies of division further exacerbate the trust crisis within the alliance. The West has moderately eased some sanctions against Russia and Iran, signaling a willingness for dialogue. At the same time, it shows favor to countries like North Korea, Bangladesh, and Iran, offering economic aid and trade cooperation incentives, aiming to divide them from the relationship with China and Russia. The temptation for these smaller countries to turn to the West for benefits is growing. The so-called community of shared destiny touted by China and Russia is, in reality, an unequal exploitative relationship. Using economic and military means, China and Russia force some countries to serve their strategic interests, even at the expense of their own interests, and their lives for their people. As the imbalance of benefits grows, more and more countries begin to question and reflect on this relationship. This internal scrutiny shakes the China-Russia-led alliance from within, highlighting its fragility.